In section 5.2, we're going to go over properties of quadratic functions in standard form and also vertex form. And I want you to be able to define and identify and graph quadratic functions and to use maximum and minimums of quadratic functions to solve problems. So first let's talk about the axis of symmetry. That's a line through the vertex of a parabola that divides the parabola into two congruent halves. Now I want you to look at the difference here between standard form and vertex form because you will be working with both of them. Yesterday you worked with standard form and today you're going to be working with vertex form and standard form. So here we have A, which would represent your stretch or your compression, minus H, A times X minus H, and H is going to represent your horizontal translation, and that gets squared, and then we add K, and that's going to represent your vertical translation. All right, let's look at the vertex form. Here we have what we just wrote up here, and this is just an indication of what each part of the vertex form represents. And so if we want to find the vertex, which yesterday you found in standard form, but when it's in vertex form, the reason why it's called vertex form is because you can easily see the vertex. The vertex is going to be HK. Now, be careful here because this is minus H, so kind of think of this as setting that equal to 0, and then you can find H. So the vertex is HK. If A, which is right here, is greater than 0, the parabola is going to open up. If A is less than 0, so if there's a negative here, if this is a negative A, the parabola opens down. So that's how you tell what the orientation of the parabola is. All right, let's talk a little bit more about axis of symmetry. The axis of symmetry, again, is a line that goes through the vertex of the parabola, and it cuts the parabola or divides the parabola into two congruent halves. And now we're going to graph a quadratic function in vertex form. So to determine which way the parabola opens, we look at A. To find the axis of symmetry, X equals H, and again, H is right here. It's actually minus H, so X equals H. The vertex is HK, which you'll find right here and here. And then you find, like yesterday, find 2 points to the left of the vertex and 2 points to the right of the vertex. All right, let's do an example here. I'm not sure if you can see this too well. It is kind of in the highlighted area, so I'll read it off to you. It's f of x equals, and then in parentheses, x minus 2 squared plus 3. All right, when we go to graph this, you have your steps up above. We want to determine which way the parabola opens, and since this is positive, so this is like having a 1 out here, positive 1, the parabola we know is going to open up. The axis of symmetry is, we set that equal to 0, solve for x, and x is going to equal 2. And then the y coordinate of our vertex is just right here. So vertex form, you can easily find the vertex. All right, now we want 2 points to the left. So just like yesterday, you find your vertex first. So this here is my vertex. And then I do 2 points to the left. So again, I usually choose 1 unit away and then 2 units away from the vertex on either side. So when I substitute 0 into here, I'll get negative 2 squared, which is 4 plus 3. So that point is 7, and then I'm just going to tell you what the other points are. I substitute 1 in here, and I'll get 4. And then I'm going to go 2 points to the right of the vertex, so that would be 3 and 4. And again, you're just substituting these values into this function to find y once you have x. So another point is 3, 4, and the other one is 4, 7. All right, when we graph that, now today you're going to be graphing the axis of symmetry. So whenever you graph your parabolas, include the axis of symmetry because that's what divides the parabola in half. Here's our vertex at 2, 3, and then we can just graph the other points that we chose, make a smooth curve. And there's your parabola. All right, now we're going to talk about the maximum and the minimum. Parabola will have a minimum if it opens up, which makes sense. You always look at the vertex, and that will give you the highest or the lowest point. So if parabola opens up, it's a minimum. If a parabola opens down, the vertex is the maximum. Now, domain, this is a set of all x such that x is an element of all the real numbers. If we take this parabola and we keep going, it's going to eventually go all the way to the left and all the way to the right, so that's why it's all real numbers. When we look at y, or our range, this is the lowest value that it can be. So you're always looking at your vertex to find your range, and here it's the highest value, so y would be less than or equal to whatever our y coordinate is of our vertex. All right, the minimum or maximum values is the y value of the vertex. It is not the ordered pair. So just y. That's why we're going to say y is greater than or equal to, or y is less than or equal to. So we're going to look at this parabola, and we need to first find the vertex, which is already marked for you. And then we want to know if it's a min or a max. Well, this is the lowest point, so that would be the minimum point. And the minimum value is going to be at y equals 2, whatever the y value is. We don't say that it's at 2, 2. We say it's at y equals 2. The domain for all parabolas that open up or down will be all real numbers. Now, later in the year, we'll look at some parabolas that open left and right. But for right now, all of our parabolas just opening up or down, and so the domain is all real numbers. Now the range, we look at the y value. The y value, the smallest value of y is 2, and all the other values are greater than that. So we say that y is greater than or equal to 2. All right, let's look at another one over here. This one opens down, so that means, and here is our vertex. Since it opens down, the vertex is the highest point on the parabola, so it's going to be a maximum. And then we want to know where the min or max is, and the max is going to happen at the y coordinate. So when y is less than or equal to 6, because the highest value on that parabola is 6. Okay, and then our domain, because it opens down, is going to be all real numbers, and our range, whoops, that's actually our range here, so let's just change that to the max happens at y equals 6, but then when we're talking about the range, it's y is less than or equal to 6. All right, last thing we need to talk about is transformations. And in section 2.6, you transformed linear functions. In this chapter, you're going to be working with transformations of quadratic functions. And I want you to remember that horizontal transformations with functions, let's put an S on that, do not behave the same way they did with points. All right, using the parent function f of x equals x squared, we want to describe the following transformations. All right, so what's changing here is I'm adding 3 inside with the x, so that makes it horizontal. And since it's horizontal, if we set that equal to 3, we end up at, set x plus 3 equal to 0, we end up at -3. So that means it's a horizontal translation to the left 3 units. All right, here we have 3 transformations going on. This 2 is the A, so that's going to represent a stretch or compression vertically because it's not inside with the x. So it's larger than 1. It's going to be a vertical stretch by a factor of 2. And then inside here, we set that equal to 0, so x is going to end up at 5 after the transformation on the x-axis. So that means it's going to be a horizontal translation to the right 5. This is going to be our vertical transformation, and because we're adding to, it's a translation. So we have a vertical stretch by a factor of 2 for this. We have a horizontal translation to the This one's actually going to the right. To the right 5, and a vertical translation up 2. All right, next one here, we have a negative sign away from the x. So we're taking the opposite of y, which means it reflects over the x-axis. And then inside here, this is horizontal. And we're multiplying, so it's either going to be stretch or compression. And since we're multiplying, we have to take the reciprocal, which is 3 over 2. And we look at that number. Since it's larger than 1, it means it's a horizontal stretch by a factor of 3 over 2. Next one. We're taking the opposite of x, so that means it's a reflection over the y. And again, remember that I told you if you have a hard time remembering if you have a reflection over the x or the y axis, just draw a quick little sketch, use maybe 2, 1. And if I reflect over the x-axis, the x stays the same, but the y goes to the opposite. So we have a reflection over the x-axis, we take the opposite of y. Okay, but right here we're taking the opposite of x, so it's going to reflect over the y-axis. And then we have adding 5 away from the x, so that means it's vertical. It's either vertical or horizontal, and since it's not horizontal, it's vertical. So it's a vertical translation up 5 units. All right, last thing that you need to do is you need to be able to write a description of transformations, or from a description, write the actual transformation. So we're starting out again with the parent function, x squared. If we want to do a vertical stretch, stretch means to multiply, vertical means the entire function, by a factor of 5. So again, when it's vertical, we don't change the number. So this is g of x equals 5x squared. If we want to do a horizontal that affects the x only, stretch means to multiply, and because it's horizontal, I have to take the reciprocal of 5. So that's going to be g of x equals 1/5 x squared. If I want to reflect over the x-axis, I have to take the opposite of y, which is the entire function. So that would be a negative x squared. If I want to do a horizontal translation to the left, now it's horizontal, and it's a translation. So horizontal means x only, translation means to add or subtract, and if I'm going to the left 3, because it's horizontal, I have to add 3 to the x. So we have g of x equals x plus 3 squared. Vertical translation up 1. Vertical means I'm adding it to the entire function, so not inside with just the x. So I end up having g of x equals x squared plus 1. All right, you have a few questions to do here, and what I'd like you to do is to add a number 5 to this graph that you're doing here, and I would like you to also tell me the domain and the range.